Hello, and welcome back to Physics with ZUKI. Today we are covering resistivity. We already learned about resistors and resistance, but how do we calculate how much resistance a resistor has? Well, certain types of materials have higher resistivity than others. For example, copper has very low resistivity since electrons can flow freely through a copper wire. Glass or plastic has a very high resistivity because it strongly resists the flow of electrons. Resistivity is a measure of how resistant a material is to electron flow. Two resistors made out of the same material can even have different resistance values. That is because while resistivity is a property of the material, that material can have different shapes and sizes. If we think of the wire like a pipe with water moving through it, we know if the pipe is longer, it is harder for the water to move through, so increasing the length increases resistance. Also, the larger the face of the pipe, the easier it is for water to move through, and same for electrons, so face area is inversely proportional to resistance. So now we can make sense of this equation, where resistance R is equal to resistivity ρ times length L divided by face area A, which is the face area of the resistor we talked about earlier. Now we can do a practice problem. We have a rod of tungsten whose resistivity is 5.60 times 10 to the minus 8 ohm meters. This tungsten is 2 millimeters in diameter and 10 meters long. What is the resistance of this piece of tungsten? First, we'll need to calculate the area. Since we have a cylinder, the area of the face is equal to pi r squared. And since we've been given a diameter, we need to remember to divide by 2 to get the radius. Also, we've been given the diameter in millimeters, so we'll want to convert it to meters to keep all of our units consistent. We were given the diameter of 2 millimeters, so dividing this by 2 we get the radius, 1 millimeter, and since 1 meter is equal to 1,000 millimeters, we get r is equal to 0.001 meters. Now that we have our radius in meters, we can plug this into our area equation to get area is equal to pi 0.01 squared, or pi times 10 to the negative 6. And now we can plug this area back into our original equation. We know ρ is equal to 5.60 times 10 to the negative 8 ohm meters, and length is equal to 10 meters. So if we do the math, we get 0.178 ohm. And this looks like a pretty small value, right? And that makes sense because tungsten is a metal and a good conductor, and therefore a poor resistor. Conductivity is the inverse of resistivity. It is how well a material conducts electrons. We can relate conductivity sigma to resistivity ρ like this. Sigma is equal to 1 over ρ. Conductivity is equal to the inverse of resistivity. So to recap, remember this R equals ρL over A equation. Remember to very carefully calculate your area. This time we had a cylinder, but you may be given a different shaped prism. And also remember that conductivity is the inverse of resistivity. Thanks for watching. Stay tuned for more circuits episodes and consider subscribing for more Physics with ZUKI. See you next time. Bye-bye.